So for Unit 5, we are doing trigonometry again, but this time we're looking more at the unit circle. So our first example is that we have 83 degrees, and we're asked to find a coterminal angle. If you want to see a visual, 83 degrees is in quadrant 1, close to the 90-degree line. So this is just a sketch. And coterminal means that we're going to be in the same position, but on another rotation of the circle. So to find a coterminal angle, we can add 360 degrees, and that'll give us 443 degrees, which is a coterminal angle to 83. You could also subtract 360 degrees, and you can do that as many times as you want to go on different rotations of the circle. So the easiest is to just add 360, which is what I'm doing to part B, and that answer would be 565 degrees. The next thing that we're looking at is points on the unit circle and angles as they rotate around from 0. So if we draw our unit circle like this, it says to find the point XY that forms a 150-degree angle. So a 150-degree angle would be somewhere in quadrant 2, because we know that we start on the right side at 0 degrees and on the left at 180 degrees. Therefore, to rotate 150, we would be around here, and that would leave us with a 30-degree related angle underneath the terminal arm with the x-axis that creates a right triangle that has an x value on the adjacent and a y value on the opposite, creating the point at the end of the terminal arm, xy. Because this is the unit circle, that means that we have a radius of 1, and therefore we have a right triangle with a radius of 1, and using the Pythagorean theorem, we can find x and y. The cos of 30 degrees is the adjacent x over the radius of 1, and the sine of 30 degrees is the opposite y over the radius of 1. Using our calculators, we see that cos of 30 degrees is 0.866 rounded, and y is 0.5. Therefore, the point is at negative 0.866 and 0.5. The reason that it is a negative x value is because we are in quadrant 2 and we had to go left of the origin. Now we're given the ratio and we're asked to find the measure of the angles. So there's more than one answer. There's actually 2 answers in each circle. And we're just going to look at the first unit circle. If I have a unit circle here, cos can have a positive 0.5 ratio if it is in quadrants 1 and 4. Remember the cast rule, and this is where cos is positive, because if we draw a point and a terminal arm, this is where the adjacent, the x value, which deals with cos, is a positive. Therefore, we have 2 answers, an answer in quadrant 1, so I'll call it theta 1, and an answer in quadrant 4 we can call theta 4. In order to find the value of the angle, we do the cos inverse of 0.5, and that gives us 60 degrees. So our 2 answers are 60 degrees for quadrant 1, and if we have 60 degrees in quadrant 4, it means we rotate it around almost to 360. So we do 360 minus 60, which is 300 degrees. And we need both answers to complete this question. For part B, we're doing the same thing with the sine ratio. This time we're looking at the sine ratio being negative, meaning we are looking at the bottom 2 quadrants where sine is not positive. We are looking at a triangle with a terminal arm in quadrant 3 and in quadrant 4. If we take the inverse of 0.5, we get 30 degrees. I am not including the negative because the negative just tells us which quadrant we're in, and we've already determined that. Now we know that we have 30 degrees here and 30 degrees in this triangle, and therefore in quadrant 3 and in quadrant 4, we have angles related to 30 degrees. In quadrant 3, we go around 180 plus the extra 30 degrees, and that gives us 210 degrees. And in quadrant 4, we go almost all the way around, so we do 360 minus the 30 for 330 degrees. Both answers are correct and need to be included. To check your answers, you can do the sine of 210 and you'll see you'll get a negative 0.5, and same for 330 degrees. The last part of this unit was graphing trig functions, and we used transformations. So if it helps, you can draw the original sine function, which starts at 0, 0. It maxes at 90 degrees to 1. At 180, it crosses 0. At 270, it's down at negative 1. And at 360, it's back at 0. I'm going to draw it with a dotted line because we are concentrating on the transformed function. We are moving it right 60 degrees and up 2. Previously, the middle line here was at 0. We are now drawing a middle line at y equals 2. So I'm going to use a dotted line here. And this is called the axis of the curve. And it always corresponds to this value here. From here, our starting point that used to be at 0, 0 is now over to the right 60 and up 2 on the middle line. What used to be at 90 is over 60 degrees, 2 spaces, and it's up 1 above the middle line. So up 2 from where it was before. 180 was at 0, right 2 spaces, 60 degrees on the middle line. 270, right 60 degrees, up 2, so 1 under the middle line. And same with the last point, we go over and up. And when we redraw our function, there is the sine curve. We should put dotted line points on the end to show that it does continue forever. To review amplitude, it is max minus min divided by 2. In this case, it's 1. The period is the length of a cycle. In this case, the length of the cycle is still 360 degrees. We just moved it, so it starts at 60 and ends at 420, which is still a 360 degree cycle. There are no x-intercepts because we were raised above the axis. And the y-intercept, we would have to calculate algebraically. So we would do the sine of plugging in 0 for x, and you can use your calculator. If I were to do this properly, the y-intercept should be at it is approximately at 1.13, and rounded is fine. And let's move on to the last example. This is an example we had in our lesson and I believe was on the original test for this unit. If we draw the original sine function, same as before, it's a good place to start from. This time we have 2 transformations occurring. We have a negative, which means to reflect, and we have a stretch of 4, which actually tells us that the amplitude is 4. So we are going to keep the middle line at 0. There was no shift up or down. Instead of maxing first, we're going to min, and we're going to do that to a minimum of negative 4. And instead of having a minimum of negative 1, we now have a maximum of positive 4. and we can connect. Okay, it should look much nicer than that. Try that again. We can connect the dots in a nice curve. Just something like that. The domain, we'll add some dots. The domain of every trig function is negative infinity to infinity, because technically it does cycle forever. The range would be from the minimum to the maximum. And in this case, the x-intercepts are at 0, 180, 360. They are every 180 degrees. So we write it as 180n, and then the y value is 0. And we can write that n exists as an integer. So if n is 0, the answer is 0. If n is 1, it's 180. If n is 2, it's 360, and so on. We will do another video for Unit 6. That is the conclusion of Unit 5.